Hi students, this is Mr. Yao. In this lesson, we are going to continue to learn more about System of Inequalities application. More specifically, we are going to learn about linear programming, and in this lesson, it's about how to set them up. Imagine a family is road tripping from Salt Lake to Los Angeles. Your hope is to get there in as little time as possible, or in other words, you're trying to minimize travel time. What are some things that could happen that would prevent you from minimizing travel time? Just think through. You might think of some examples like you might need to take a bathroom break, or you need to stop for gas, or you need to actually charge your car if it's, like an electric car. Might not be able to drive that far. There are a lot of these little elements, these factors that could affect your travel time. These are all called constraints. There are things that limit you in your goal to get to your destination in as little time as possible. So now let's think about another scenario. Have you flown on a plane? And what kind of seats did you get? Have you ever wondered how airlines actually set those ticket price? Think about this. Here, well, of course, not exactly the same as real life situation, but it's similar. It's actually just a simpler version of that. An airline offers coach and first class tickets. For the airline to be profitable, it must sell a minimum of 25 first class tickets and a minimum of 40 coach tickets. The company makes a profit of $225 for each coach ticket and $200 for each first class ticket. At most, the plane has a capacity of 150 travelers. How many of each ticket should be sold in order to maximize profits? And this is a pretty important thing for business to actually consider because they don't want to go bankrupt. They, of course, want to make money. So they want to maximize profits. And this kind of thing is actually called linear programming. So let's define it. Linear programming is a systematic process of finding the maximum or minimum value for an objective function with certain constraints in the form of linear inequality. It is also known as optimization problem. Linear programming is helpful in developing and solving a decision-making problem by mathematical techniques. We typically could use it in advertising businesses to make the most efficient and effective use of the scarce resources, and of course, maximize revenue and profit. So this is the basic definition of this mathematical model called linear programming. Let's understand a bit more about it. Objective function is the function we're trying to maximize or minimize for, such as profit or energy. That's why in the previous lesson, we actually reviewed about story problem because these objective functions would come up as similar setup as the story problems you work in the previous lesson. If you actually missed that or you struggle with that, please go back and review that lesson. And then the constraints that we just talked about, they're limitations such as time, funds, material, etc. Because these are real-life situations, besides setting up inequality that's actually given or provided in the question, we also have some of them that are not provided. They're called non-negativity constraints. Like x is greater or equal to 0, y is greater than or equal to 0. We actually have graphed them in the previous lesson in 3.8b. For example, there's no negative amount of cars sold or no negative amount of people. So these are just how real life works. It just doesn't work that way. There's no negative amount of people. So you have to set it up as greater than or equal to 0 as constraints. And then if we're talking about business and we're talking about profit, of course, we're going to have cost, which is how much money you spend to be able to actually make something. These are like your resources, the money you spend on resources. Revenue is how much money you actually earned. Well, let's say you sold 10 cups of soda, $2 each, you made $20, and that's your revenue, but that is not your profit. Profit is how much money you actually made, and profit is revenue minus cost. So you have to get rid of the money subtract the money that you have already spent. Even though you earned $20, that's not the actual profit because you might have spent some money to buy cups or to buy lemonade, jugs of lemonade. So that would need to be subtracted. Moving on. Now let's see some examples. Example 1. A homeowner is making plans to landscape her yard. Grass rod is supposed to be rod. Installation costs $2 per square foot, and floor bed installation costs $12 per square foot. Write an objective function So it's writing a function, but this function we're writing is an objective function to present her potential cost for the project. Since it's about cost, let's actually use letter C. And the two variables that we are involving, well, grass, so it's going to be a letter G, you can use letter G. And then flower bed, we can use letter F. So the function is actually about G and F. Previously, you might have seen just like f of x. Well, that's a function. Now we're just using a different letter C to present the function. And the variables involved is a G, comma, F, because you have two different variables. Okay, $2 per square foot for the grass, so it's going to be 2 times G, and $12 per square foot for the flower bed, so it's going to be a plus 12F. There you go. That's the objective function. Then, of course, later you might have other constraints. Then you can start limiting on what G could be and what F could be. Then you can start calculating the actual cost. But no matter what, how many square foot for the grass or how many square foot for the flower bed, you're going to need to calculate the cost this way. So that is the objective function. Let's practice more. Example 2. A vendor at the Saturday market makes $9 profit on each necklace she sells and $5 profit on each bracelet. Write an objective function to present the vendor's potential profit. Well, the word is profit. We can use letter P for the function. The two variables, well, it's necklace and bracelet. So we can just use letter N for necklace and letter B for bracelet. N, comma, P. $9 for each necklace, so it's IN. $5 for each bracelet, so it's 5B. There you go. That's our objective function. Moving on. Now it's a longer question that involves inequalities. A calculator company produces a scientific calculator and a graphing calculator. Long-term projection indicate an expected demand of at least 100 scientific and 80 graphing calculator each a day. Because of limitations on production capacity, no more than 200 scientific and 170 graphing calculator can be made daily. So there you go. You can see these two numbers are both about the scientific. And then these two numbers are both about the graphic. So that kind of gives you some idea already. To satisfy a shipping contract, a total of at least 200 calculators must be shipped each day. If each scientific calculator sold results in a $2 loss, but each graphing calculator produces a $5 profit, how many of each type should be made daily to maximize net profits? We're not actually calculating it today, we're just learning how to set them up. So first, we got to pick our variables. So let's say letter S is going to be our scientific, and letter G is going to be our graphing calculator. Okay. Next, let's actually start understanding more about, say, scientific first. You need at least 100 scientific calculators, but no more than 200 scientific calculators. So in other words, you need scientific calculators to be in between the 100 and 200. So here's how we can write that. We have learned how to write between, which is a compound inequality. So 100 is less than or equal to x, which is less than or equal to 200. So there's your limitation for the scientific, which is our first inequality. Next, graphing. At least 80, and then no more than 170. So it's the same thing. It's in between 80 and 170 for the graphing. Oh, so it's not x, this is s. So it's going to be 80 is less than or equal to g, which is less than or equal to 170, because we're trying to write in between. So that basically dealt with all the numbers in the first two statements. Moving on, to satisfy a shipping contract, a total of at least 200 calculators. It didn't say if it's scientific or graphing. It just says a total of 200, at least 200 calculators, which means we need to put all the calculators together. So it's going to be an S plus G, but it's at least 200 has to be greater than or equal to 200. There you go. But let's not forget, you can't sell negative amount of calculators. So of course, you also have the S is greater than or equal to 0, and the G is greater than or equal to 0. So these are all the inequalities, or in other words, these are all the constraints. TRAINTS. So these are all the constraints, which are all the inequalities that we have. Now let's talk about, in order to calculate the profit, well, we need an objective function. So let me write that down. Objective function. Okay. Since it's about profit, let's use letter P. And the two variables we have is S, G. For scientific, is a $2 loss. Be careful with that. So it's actually not making profit. You're losing money for scientific. So it's going to be a negative 2S. But the graphing calculator is making a $5 profit. So it's going to be a plus 5G. There you go. That's example 3. Now it's actually a very thorough setup for linear programming. Of course, today is just a setup, and next lesson we are going to learn how to actually use the graph to actually maximize our profit. Moving on, example 4. You need to buy some filing cabinets. You know that cabinet X costs $10 per unit, requires 6 square foot of floor space, and holds 8 cubic feet of files. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. You have been given $140 for this purchase. Well, okay, that's an important, which is like a budget, though you don't have to spend that much. The office has room for no more than 72 square feet of cabinets. How many of each model should you buy? Well, let's set the variable first. So cabinet X. Well, we can just use lowercase x. Cabinet Y, we can just use a lowercase y. Okay, let's start thinking about it. First, we're going to need to think about the cost. Well, and you only have $140 cost, so these two are for sure going to be related to your cost. I'm going to write the word constraints, because it's all of the inequalities we're going to set up are going to be our constraints. But the third thing we're going to set up is the cost. Okay, $10 for cabinet X, so it's 10X. $20 for cabinet Y, so it's going to be 20Y. In total, you can only spend $140, so you can't go over that, which means it has to be less than or equal to 140. So there you go. That's our setup for the cost. Next, space. Because this is where the sentence kept telling you about these phrases that indicates inequality. No more than, well, let me actually choose a different color. No more than 72 square feet. Well, now it's about space. So square feet is right here, 6 square feet, 8 square feet. So 6 square feet for cabinet X, which is 6X. 8 square feet for cabinet Y, so it's 8Y. Altogether, no more than 72 square feet of cabinets. So it's going to be less than or equal to, because it's not more than, so it's less than or equal to 72. Next, you might be like, wait, but then we have this like files. Well, the question is actually asking about maximize the storage volume, which in other words, you're trying to maximize the amount of files you can actually hold. So that is not going to be part of the inequality. That's going to be what you're calculating, which is the objective function. But you're going to have some cabinets. You can have negative amount of cabinets. So that means our x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Lastly, the objective function. Again, the objective function comes from what the question is actually asking. The question is asking about storage volume, which in other words is about how many files. So objective function, since about volume, let's use letter V. The two variables we have, x and y. 8 cubic feet of files for cabinet X, so 8x. And then 12 cubic feet of files for cabinet Y, so plus 12y. There you go. That's all the setup we need for example 4. Moving on, last example, example 5. Toy company builds toy cars and trucks. To make each car, the company needs 4 wheels, 2 seats, and 1 gas tank. To make each truck, 6 wheels, 1 seat, and 3 gas tanks. The storeroom has 36 wheels, 14 seats, and 15 gas tanks. The company is trying to decide how many cars and trucks to build so it can make the largest possible amount of money when they're sold. So how the company figure out how they should spend their resources building cars and trucks so they can make the most amount of money possible if they profit $5 for a car and $7 for a truck. So that means our variables would be about car and truck. Okay, so let's see. It's asking about profit. So you already know the objective function is going to be the profit. Well, let's pick the two variables. One is about the car. We're going to use letter C. The other is about the truck, so we're going to use letter T. That means in the objective function, it's going to be C, comma, T. Okay, let's not worry about that. Let's actually try to set up the constraints first. So, constraints. Some of you might be like, wait, but this question doesn't have anything mentioned about like those no more than, less than, those kind of inequality phrases. Well, let's go back to read the question. The storeroom has 36 wheels, 14 seats, and 15 gas tanks. So this is like a hidden piece of information of inequality, because this is almost like your budget. Like you can't have more than these resources. So in other words, resources would actually work like budget, and they are going to give you the inequality. You can't go over them. So let's see, 36 wheels to begin with. Well, wheels, we have 4 wheels for the car and 6 wheels for the truck. So wheels, 4C, and then 6T. You only have 36 in total, so I can't go over that, so it's less than or equal to 36. Next, seats. You have 2 seats for the car, 1 seat for the truck. So it's 2C plus 1T, but you only have 14 in total. So it's less than or equal to 14. Next, we have the gas tank. Well, 1 gas tank for the car, so it's 1C. 3 gas tanks for the truck, so it's 3P, which is less than or equal to 15. There you go. These are all the numbers that we have, except the profit. Well, the money is going to be our objective function, which is the profit. Lastly, you're making cars, you're making trucks, they can't be negative. So it's going to guarantee to have C is greater than or equal to 0, and T is greater than or equal to 0. So these are your 5 constraints. And then the objective function. The objective function is the profit. You have $5 for a car and $7 for a truck. So it's going to be 5C plus 7T. That's going to be the total amount of money. Well, that's going to be the total amount of profit that you can make for the cars and trucks. So that is example 5. In the next lesson, we are going to learn actually how to decide the maximum profit. Thank you.